All right, we're just going to do maybe A and C of this one. So we've got x to the power of 4 plus 1 equals, and you've got those two brackets. If I'm looking at A, let's say for A, if I need to find A and B, what I can do is just have a look at different coefficients. For example, the coefficient of x cubed, of course, is 0 on the left-hand side. And then if I look on the right-hand side, I would get x cubed from that x squared times bx, so that's b. And I would also get it from ax times x squared, so that's plus a. So we can already see from that that a has to equal negative b. If I look at the coefficient of x squared, so let's get rid of that bit. So now x squared, how would I get x squared? I would get x squared times 1. So that's going to, sorry, look on the left-hand side, of course I've got 0. Then I've got 1, and then I'm going to get AB, because that would be AB. And then I'm also going to get another 1 there. So you can see from there, we're going to get AB is equal to negative 2. Now, if you put those together simultaneously, so really subbing A equals negative B into the second one, I would get negative B times B, so negative B squared equals negative 2, so B equals plus or minus root 2. And because A has to equal negative B, at the same time A would equal then negative positive root 2. Right. All right, and if I then have a look at, let's say C, if I look at C now, I'll do the same thing. So if I find the coefficient of x cubed in C on the left-hand side, was I doing x cubed? I'll do x, yeah, I'll do x cubed. So I get 0, and I'll get exactly the same thing, won't I? So if I'm doing x cubed, I will still get this same thing that we got here before, which is a equals negative b, because it's exactly the same. But for x squared now, I've got a coefficient on the left-hand side. So on the left-hand side, it's negative 1. And on the right-hand side, it's still 1 plus ab plus 1. So those are still the same. So this time I'm getting ab equals negative 3. So again, subbing in a equals negative b, I'm going to get negative b squared is negative 3. So here I'm going to get b equals plus or minus root 3. And a is still equal to negative b, so a equals negative positive root 3, right? A is still equal to negative b. So show that all these resulting quadratics are irreducible. Okay, so if you have a look at what we're getting here, for our A's and B's, if I just get rid of this for a second, we can, you know, if we look at that first bracket, what's the discriminant of that bracket? So b squared in this case is a squared, minus 4ac is minus 4. If I look at this bracket, the discriminant is b squared minus 4ac, so 4 here. So you can see that the first bracket is irreducible. I can't factorize it any further if that discriminant is less than 0. And so we could solve for that. So you could do it two ways, a minus 2, a plus 2. So we want that to be less than 0. So this is a happy parabola in A where these are minus 2 and 2. So where is this less than 0? Here. So if my A is between minus 2 and 2, then this is going to be irreducible. So let's have a look at A. Our A in this case was plus or minus root 2, which is between negative 2 and 2. And our A in this case was plus or minus root 3, which again is between minus 2 and 2, because between minus 2 and 2 is the same as negative root 4. A is less than A, which is less than positive root 4. So I suspect that they must all be between negative 2 and 2 for A. And if we look at this one in the same way, we've got b minus 2 and b plus 2, and we want that to be irreducible. So we're really just changing this to b's now. So again, we want b to be between minus 2 and 2, and we can see, yes, it is. So that's why they're irreducible. We can't reduce them any further. We can't factorize them any further. Because the discriminant, we don't have any roots, right? So the discriminant's less than 0.